Everybody's talking about AGI, right? Artificial General Intelligence. But beyond all the hype, what are the actual, real technical roadblocks that are still in the way? Okay, let's dive in and really look at what the people building these systems say is the missing piece.
So we're going to kick things off with this bombshell from the CEO of Google DeepMind, Demis Hassabis. He is just flat out calling the idea that today's AI operates at a PhD level nonsense. And you know what? This one comment sparked a massive debate, and it gets right to the heart of where AI truly is today versus, well, where we think it is. So, first up, the AGI reality check. We're going to jump right into that debate that Hassabis started and his core argument about the, well, kind of strange and uneven capabilities of modern AI. Hassabis uses this great term for it, the jagged frontier. What he means is that AI's intelligence isn't some smooth, upward climbing line. Nope. It's more like a series of really sharp peaks and super deep valleys. An AI can perform a task that requires incredible, world-class expertise, and then, in the very next moment, fail at something a child could do.
And this illustrates that jagged frontier perfectly. I mean, on one hand, you have AI making genuine, non-intuitive scientific discoveries or writing entire academic papers, but on the other hand, just like Hassabis points out, that exact same system can make silly mistakes with high school math or just basic counting. That is not what a general intelligence looks like.
Okay, so that's a pretty strong case from one of the biggest names in the field. But is he right? Do other experts see it the same way? Let's find out. And right away, nope, we've got a direct counterpoint from Harvard professor David Sinclair. He's not just talking theory here. His lab is actually using an AI that he says is easily performing at a PhD level, making discoveries and even writing the papers with zero human help. I mean, that sounds an awful lot like a PhD intelligence to me. And here's another one. Professor Daria Anutmis has actually trained human PhD students, and her take? Today's top AI models operate at a much higher level than the students she's worked with. She kind of suggests Hassabis might only be right if he's talking about, the top 1% of genius-level PhDs. But then we get this more nuanced take from inside OpenAI. Aidan McLaughlin actually agrees with Hassabis, you shouldn't go firing your human researchers. But he reframes the whole thing. The point isn't that AI is a PhD replacement, it's that it gives everyone a PhD in their pocket, which basically democratizes access to expert-level knowledge. So while all these experts are debating the high peaks of AI intelligence, they all seem to agree on one really deep valley in that jagged frontier. Let's just call it AI's amnesia problem.
The fancy technical term for this problem is the lack of continual learning. This is the ability that we humans have to constantly absorb new information and just get better at stuff over time. Current AIs are fundamentally missing this. Once they're trained, they are pretty much frozen in time.
This is maybe the best analogy for it, from OpenAI co-founder Andrej Karpathy. He says, large language models are like a coworker with amnesia, like from the movie Memento. They can be absolutely brilliant in the moment, that's their short-term memory, but they don't build long-term knowledge or expertise from your interactions with them. And this highlights exactly what makes human learning so darn powerful. It's not just our raw smarts. It's our ability to build up context over weeks and months, to really think about our own mistakes, and to make these tiny little improvements with practice. As podcaster Dwaresh Patel puts it, it's a deliberative, adaptive process that AI just doesn't have right now. So solving that grand challenge of continual learning, yeah, that's going to be incredibly difficult. But there's a more immediate, more tangible piece of the puzzle that all the major labs are working on right now. Simply giving these models a better memory. And hey, this isn't just speculation. OpenAI CEO Sam Altman has said it directly. He says people want memory and that it's a huge focus for their next generation models. I mean, even the basic memory feature in ChatGPT today fundamentally changes how you can use it for long-term projects.
But some folks, like Andrew Piganelli, are making an even bolder claim. He's arguing that memory is the final piece of the puzzle. That once you combine today's powerful AI processors with a truly robust memory system, you're not just getting close to AGI, you're basically there.
So we've got this huge roadblock of memory and learning. But what if there's a shortcut? A surprising number of experts believe the fastest path to solving these problems runs directly through a very specific domain, writing code.
This is Sean Wang's Code AGI theory. The core idea here is that an AI that can truly code at a high level represents a massive shortcut. He believes it can be done in just 20% of the time it would take to build a full AGI, but it would unlock 80% of the economic value. That's a pretty good deal.
Okay, but how does that even work? Why is code the magic key that could suddenly accelerate the entire field toward AGI? So the crucial point, as explained by Nick Pash, is the data. It all comes down to data. When developers use AI coding tools, those platforms get this priceless stream of real-world data. Full code bases, error logs, user preferences, you name it. This data is exactly what the big model labs are starving for. It creates this amazing feedback loop, where the platform data is used to train better models, which in turn unlocks even newer coding capabilities. So, how does all of this come together? We've talked about jagged frontiers, amnesia, coding agents, but why does this path to AGI actually matter to you and me? Here's the most important takeaway from all of this. Getting bogged down in defining what AGI is, it's a distraction. The truly important things are the new capabilities that are being unlocked as researchers try to solve these big problems. The journey is way more impactful than the destination.
And this is what it means in practice, for you. When AI gets better memory, you get a personal assistant that actually knows you and your context. When it finally nails continual learning, we're going to see truly autonomous agents that can manage complex business workflows. These are the breakthroughs that will change everything, no matter what we decide to call them.
Which leaves us with a pretty fascinating final thought. We tend to think of the path to superintelligence as this quest for just more and more raw processing power. But what if the next great leap forward, the thing that unlocks the next level of capability, isn't about being smarter, but is simply about remembering?